So to draw the solid, you first of all need to place your ruler in such a way that it's going to have to be straight on your paper. Then slot in your set square. Now you want to get 30 degrees. Now when you slot your set square, you are going to use this part of the set square to draw a line on the base. Now there, this is the line. Now again, the next thing you're going to do is you will flip your set square, that's take it the other way, make it like this, then place it on your paper. Placing that on your paper now, we're going to get for this other side here. There, and this is the other line. Now the reason why this line is longer than this one, it's because if you look accurately at the dimensions, on this side says 14 centimeters and this side says 3.5 centimeters. Now let's label the center to be 0 or O, letter O if possible. Now on this axis you're measuring with 3.5. Measuring 3.5, we get the point. Now this is the point, 3.5, and we'll call this A. Now on this line you're also measuring what, 14 centimeters. Now you see how long it is. Now AO, 14 centimeters. If this is the point here, if there's a point here, we're going to call this B. Alright, so what we're going to do next is to project lines from point O up, A up as well, and then B up as well, and we're going to be measuring 5 centimeters in that. Now we're going to place our set square straight like this from point 0 or point O, whatever you want to call it. We'll raise a line up here like this. You can see the line. Now we'll move this set square to point A as well, and we're going to raise a line up from this point. So this is the line, and then we'll move all the way back to point B here like this. We're going all the way back to point B here, and we're going to have to raise another height up. Okay, now there we have it. So next we're going to do is from point O, the line coming from there, we're going to measure 5 centimeters. Now this is 5 centimeters. That point indicates the height for our isometric solid. Now we're going to repeat 5 centimeters too for all other heights. Here measuring 5 centimeters, then we'll come all the way here and we'll also measure 5 centimeters. There. Now you can see all 3 points: 5 centimeters, 5 centimeters, and 5 centimeters. Now what we're going to do is join these points together with the aid of our ruler. If you can use your set square, no problem. Now this here, this is the line. Take a set square, the line as well. Now place your ruler at the base of this one. Calibrate your set square just with this line. Then slot your set square forward to this point and then draw. Flip the set square the other way like this. Push forward to this point and draw as well. Now, whatever excess lines coming from the main frame, you have to clean it off. and you have the isometric block. Now on the next step I'm going to show you, we're going to be sectioning our isometric block into various parts to make it look like the solid we want to achieve. Now we were told that from point O and somewhere on the height we have 2 centimeters. We're going to measure that on both sides. On point O, measure 2 on the height. From point A, you also measure 2 on the height. And then, with the aid of a ruler, you join respectively. Like this. There. And likewise, when you set your set square below the base, when you bring this 30 degrees, it's going to have to transfer from that point of reference to another point at the back, like this. Push it forward to this point, and you have another line right here, as you can see. Now, next thing we're going to do, we're going to come to AO and we're going to dissection the breadth. Recall our breadth was 3.5, but if you look closer, we can be able to section our breadth into different entities, and of which it states a 1. After that, you measure on the 1.5, and then lastly, you measure 1 centimeters. So let's do that. So now, I'm not going to actually rush it, so all I just need to do is take from 0 to 1. And then from 1 at the same time, from 1, I can take 1.5 from there, and when I add 1.5 to 1, I have 2.5. And this is what I have. I repeat the same thing too from the top to provide accuracy, 0 to 1, like this. And then from 1.5, step out, that gives you 2.5, and I can use my ruler to join the 2 points together respectively. This. Also from here I can do the same thing too, and this is what I have. Now, placing your set square on the ruler, slide it in such a way that it's going to have to meet this point here. So when I push this one here, that's the first point, I'm going to have a line that goes all the way in, and I have to be very careful here so I do not let the lines intersect. So I'm going to draw my line coming all the way from this point in, and you can see it. Next, I'm going to have to slot the set square forward to meet this point here, and then I create another line. Last, I'm going to do this one. I'll create another line, and then finally this other one here. You see, you're going to be doing this 4 times because there are 4 different points on the plane. I'm going to draw this in as well. Now you see, then apart from that, after getting the lines, I do not need this line any longer, and I do not need this line any longer. Likewise this one, so I'm going to rub it off. Now coming to this point here, I'm going to take from this point. Now with my ruler, I'm going to place my 0 there, and I'm marking out 1.5 centimeters on this line. I'm going to do the same thing on the side as well, 1.5 centimeters as well, there. And I'm going to draw a faint line running from that point to the other. It's going to be a faint one because the line is not actually necessarily demarcating the solid, it's just to create a midpoint for the curve, as you see in front. A straight line. This is it. So now whatever midpoint line I'm drawing from this point here, probably maybe here, to connect with this one, is going to get me the circle I need for a curve here, and for the other one I need on the outside. So now to get the midpoint, we need to divide 3.5 into 2 equal halves, and that is 1.75. So we're going to measure 1.75 on our ruler. From 0, I believe this is 1, this is 1.5, this is 1.75, and here's the point we need. Now that's our midpoint. So from there, we're going to use our set square, calibrate with the line here, your set square, and then we're going to draw a broken line from that midpoint to connect with the other opposite line from the edge. Now this line is going to serve as the center for our circle, or the center for the curves that we need when drawing in isometric. Now for safety and accuracy, we're going to be considering the bigger curve from the outside, and I think the radius for that, it's 1.75. so when we want to measure 1.75, we have no choice but to approximate. And since we can't get 1.75 on our ruler, or if we want to be able to do that, we will need a much more let me say tactical ruler or mechanical ruler for that. So we're going to be taking 1.8 approximately to be on the safer side. Hence 1.8 from the center. Now this is the center point. 1.8 from that point is all we need. So place your ruler gently on the line. 0, this is going to be 1, and then we're going to be taking 1.8 firmly around here. That's 1.8 in point. Now also we're going to be taking it down as well. 1.8. Now be careful, because the line is going to have to come out, so I'm just going to actually use it around here. 1.8, and I just need just the point and the extension coming out from this line here. That's all I need. There, 1.8. Alright, so 1.8 up, 1.8 down. Now to place one side of a curve, just get your compass, mechanical compass, place at the point extension, which is this point right here, and then you extend it to meet with this point right here, and then you get a curve that runs all the way to touch this boy right here. So we're going to be doing that now. Place your compass on that point, extend. It seems like this is not enough. We're going to extend to touch this point, and then we're going to draw a semicircle that's going to curve and touch this point all the way. Okay. There. Now that's the curve we need. Now we're going to have to deliberating on how to get the curve from this point to touch this base. To get the curve running from this point to touch this point, all we need to do is create an extension line. Extension lines are important when dealing with this kind of curves, because with that we can be able to understand how to get our long diagonals and how to also get the short diagonal we need for an intersection to get the curve, because those are the two principal things that we need. So extend the set square to that point, project from that point to make this base here. Now where that meets, kindly trace from that point towards the center midpoint, as you can see here like this. Now that's going to serve as half of a long diagonal. For those of you that know how to plot the isometric circle, you know you need a long diagonal and two short. That's going to get you an isometric circle. Although there are other methods for plotting an isometric circle, but this one is way accurate. So from this point, you're going to take a short diagonal running from here to here. Please do that. And if possible, you want to break it because of too much lines, no problem. Just be careful when you're doing it, so you don't mix up the lines, and it's easy for you to pick your point. Now the intersection is right here, and there is where you're going to place your compass. Now I'm with the compass. You can see the intersection from the long diagonal. This is it, half of a long diagonal. If I'm to complete the remaining half, it's going to run all the way to somewhere around here in the point, but we don't need that. Now just half of this and one side of a short diagonal, which is this one. It gives an intersection of the midpoint axis right here. So this is where we're going to place our compass. We'll place your compass here, then shrink the compass to meet this point right here. If it meets that point right there, it's going to be able to create the curve you need to join this one to this one together. There, right there. So I'm going to place my compass right there, and I'm going to draw the curve I need to touch this one right here. So that's that for that, and there is no extra trouble. Now we're not going to be considering the inner curves yet. We first of all need to get the outer ones first, and I'm talking about the cylinder at the center right here. Here's a cylinder at the center, so we need to get that and come all the way down to the base and then the back before we can now continue to plot the inner curves at this axis. Although if you want to do that first, no problem, just apply the same tactics we used at the outer curve here, and you will get an inner curve joining this line and this line together as you see fit. All right, so without further ado, let us get to the center cylinder. Now, if you must get to the center cylinder, all you need to do is first of all note that if you look closely, there is a little spacing from this point down and from this point as well up, and then you will not have a passageway for a particular thickness for the line where the cylinder is actually going to have to rest. And I think the thickness of that line is 10 centimeters, but we have a height of 2 already. So if you want to be able to get 10, you need to first of all take away 10 from 20. Now 10 from 20 gives you 10. Now when you divide 10 into 2 equal halves, you have 5. So 5 up, 5 down, 10 at the middle. So those are in millimeters. In centimeters, we are trying to say 0.5 up, 0.5 down, and 1 at the center. All right, so that's what we're going to be doing. Okay, this is 0.5. We've taken that. Well, this as well is 0.5 to this point. We've taken that. Now that leaves us with whatever we have in between is going to be 1 centimeters, as you can see, 1 centimeter. So that's where we're going to be using our set square to project from. Now bring the set square to this point right here. Project the line coming from that point all the way to meet B. Repeat the same thing for the other top point. Project all the way to meet B as well. Sorry. Okay, now this is what we're going to have, and then next we're going to do make your set square straight, perpendicular with your ruler, and then you are going to exactly do a kind of like a fancy line running all the way from this point to this point. And now when you're drawing your straight line, it's not going to go all through the drawing. It's just going to come from this point down, a bit of pause, and then from the other one down again. Now you're trying to cut all ties with the remaining line from this point up and this point to B. So if you're trying to tell the engineers that we don't need that line anymore, because this is where the boundary for this curve ends, and as such you are cleaning this line off and this one off. Now if you look closely at the dimension of the cylinder at the center, before we can be able to get the cylinder at the center, we first of all need to project a line coming from the center of this small embedded curve to the center of the cylinder as well, and that in millimeters read 75. So to do that, we need to measure 7.5 centimeters on our ruler. So when we place our ruler back to where it all started, this center point, our zero is meant to rest at that center point, because it's through that center point we used to get this curve, and because of that we will need to project another line as long as possible, because we are still not ending there, we still need to go further. So we're projecting a line, more and more, if possible broken lines all the way, so we don't confuse ourselves with too much lines. Now that point we need approximately 7.5. yes, that's what we're going to be measuring, 7.5, and this is 0, so 1 2 3 4 5 6 7, and this is 0.5 right here, 7.5. now if this is the point, we are trying to tell us in that drawing that the center of our cylinder is going to start from this axis, and when it comes, it's going to rest on top of this solid. If definitely not, it's going to, I think, actually interact with the line coming from here, and then you see the rest coming all the way to the bottom and downward. All right, so we need that as our center point, and we would have to project this line, that's this line from here to this point, to cut this, so we can be able to get the base of our cylinder. Now we created a line as long as this. Now if you're wondering how I got this line, all you just have to do is transfer this one or this one to this point with the aid of a set square, so make sure it's long enough. All right, now looking closely at the center of the solid cylinder, we have a 22.5 radius, so that is approximately about 23. Yes, that's 23 in radius. That's if we approximate, because one thing about isometric circle is for you to be able to get the circle accurately, you need all sides to be equal. That's all sides of the axis square to be equal and accurate. So 22.5, yes, no problem. But to do that, we cannot be able to ascertain for that on our ruler. I said the only way you can do that is if you are using a much more advanced ruler. But in my case, since I don't have that, I'll have to make do with what I have. So I'm approximating. So that's 23. Hence, in centimeters, I'm using a 2.3 centimeter. So what I will do, I will come to this point. This is going to be my point of reference. I'm measuring 2.3 up, 2.3 down, 2.3 left, and 2.3 right. Okay, so let's do that. 2.3 right here. This is 2.3 left. This is 2.3 up. This is 2.3 down. And lastly, the final 2.3 we need. Right there.